Okay, and the way this works is, you know, we click. I'm going to click. Or actually, I don't want this. I just want click Manage Classes. So this is what we have. 102C. Quick poll here. All right, and so you guys should see, if you once you've logged in, you should see this 102C. I don't know, September 28th. And the question, I think, just says A, B, C, D, or D, or E, or something. All right, so just choose like answer choice A or something. And this is how we're going to take attendance, because when you click your responses, it records your name and stuff like that. Okay, so you just log into the online poll, and then you respond. I'll put up and I'll say, you know, just choose one of the answer choices. It doesn't matter. We'll say answer choice A for today, and you respond, and it records. It records the people who responded, right? So here it says 62 people so far have responded, and you know, it's got all of your names here. Okay, and so this is how I'll take attendance. All right, is that okay? This works. So you just log in. If you're having issues, let me know after class. We don't really have time to take care of that right now. Okay, I'm going to take attendance this way most of the time. If I remember, I'm just at the start of the class, I'll start up a poll. You just log in, choose one of the answer choices. Simple enough. Okay. Here's the thing, though. There's no like GPS tracking on this to make sure that you're located in the classroom when you respond to the poll. And in the past, students have not been honest when responding to the online poll. Okay, and let me check our syllabus. According to our syllabus, I think attendance makes up, I think I said 3%. Yeah, so class attendance will count for 3% of your total grade at the end of the class. It's not a huge deal. Okay. But if you're dishonest about this, then you're going to get I'm going to give you a 0 for your attendance grade, okay? And so at some random point in the quarter, I might do the online poll, get responses, and then at the end of class, I might do an actual roll call where I read your names and see if you're actually here, okay? And if there's a mismatch, then I know you've been dishonest, okay? And if that's the case, then that means I can't trust any of your other responses to the online poll, and you're going to get a 0 for the attendance grade, okay? End of the story. Just be honest. If you're here, you get your point, okay? If you're not here, don't like try to cheat the system and log in from home and say you're here, okay? That's all right? It's not that big of a deal if you miss class, okay? I mean, of course I want you to come, and that's why I take attendance, and I'm giving you basically free points just for showing up. But if you're not here, if you have something going on, just miss class, lose a tiny, tiny little piece of your grade, okay? And life goes on, right? If I take attendance every single class, and I'm probably going to forget to do it a few times, but let's say we take it like 20 times during the quarter, okay? If I take attendance 20 times and it's 3% of your grade, then each attendance session is worth 0.15 percentage points of your total final grade, okay? It's not worth lying and becoming categorized as a dishonest person for 0.15 points of a grade, all right? Just like your integrity is worth something, and I'll tell you, it's worth a lot more than 0.15 points of a grade, okay? And you know, you might have a good reason for missing class. That's fine, okay? I don't care if the reason why you missed class is because you wanted to stay home and watch TV. That's fine, okay? Just don't try to get your attendance point when you do that. So anyway, that's my rant on this. We're going to take attendance this way. But just be honest, I might do an actual roll call at some point. Okay, let me just go over other parts of the syllabus, and then we'll get started on the class. Okay, so anyway, my designated office hours for this class are Wednesdays and Friday mornings at 10 and Wednesdays at 10 and Fridays at 11. And if those don't work, just send me an email. We'll set up an appointment. Okay. We'll have two midterms and a final exam, and these are the dates and times for those things. I was expecting you guys to have taken 102A already, but apparently that's not the case. But anyway, I expect you guys to be at least comfortable with R. Okay, so Stats 20 should at least get you somewhat up to speed, and some of you might have to get accustomed to the heavier programming load than usual. Okay, we're going to use two textbooks, Introducing Monte Carlo Methods with R and Doing Bayesian Data Analysis. Okay, both of these textbooks are free to you. Digital versions are free as long as you're connected to the UCLA network. Okay, so all you have to do is you click this link. All right, well, okay, and there you go, and now you can download the PDFs of the textbook. I mean, chapter by chapter and stuff like that. But it's free as long as you're connected to the UCLA network. If you want to spend $100 and buy a textbook, physical version, you know, that's your money. You do what you want with it. But I try, most of the time I try to get textbooks that are you know, part of our online library. I'm not always successful. 102B, you have to actually buy the textbook. Okay, we're going to have some homework, and it's worth a lot of your grade because I feel like you're going to be spending a lot of your time doing homework. So that's why it's weighted as such. The way the homeworks work is I'm going to post an R Markdown file. Anybody not familiar with R Markdown? Okay, so everybody's used R Markdown? Oh, you haven't? Okay. So I'm going to upload a file, and you open it with RStudio. Okay, you guys have RStudio on your computers. Okay, and then you fill in your answers, and then you click Render or Knit, the button, and then it turns the R Markdown file into an HTML file, and then you submit your HTML file. Okay, so that's how it's going to work. If you're not sure, ask your classmates, and we'll do that. It's very important that if the homework asks for an answer, that the answer is printed out and displayed in your submission. Okay, so here's just a silly example. If I say print out the first 10 numbers of the Fibonacci sequence, you might write this code, and this will produce the Fibonacci sequence. However, if you submit this, you'll get 0 points because it didn't print anything out, and we have no idea what this code does. Okay, we're not going to try to parse through each line of code to figure out if you did it right or wrong. Okay, so if you just take the exact same line of code and then you include this line that says print out the object X, and it shows us the numbers, you'll get full credit for this response. Okay, so and it might feel unfair because in both cases the code is exactly the same. The only difference is printing out the answer, but that's very, very, very important. Okay, if we can't see the answer that was produced, we have no way to grade it. Okay, and we're not going to go line by line through your code to see if it's working. Okay, so make sure before you submit your homework, make sure you read through the homework yourself and make sure that all of your answers that are requested do actually appear in the homework. Okay, so that's how it goes. Okay, late policy for homework. Homework assignments are generally due at 6 o'clock in the evening, and that's so you'll turn in your homework and you still have the rest of the evening to have fun. Okay, so it's due at 6, and then if it's late, it's 5 points off per hour. All right, I have a grace period of 10 minutes. All right, so if you get it in by 6:10:59, no penalty, okay? 6:11, 5-point penalty, okay? 5 points off per hour, but it stops at midnight, okay? So when you turn it in at 11:59, it'll be 30 points off, okay? And then I suspend the point losses until the following day at 6 p.m. Okay, so just because I want you guys to get sleep. Okay, so if you didn't finish it the first day, all right, midnight strikes, just go to bed. Okay, wake up and keep working on it. All right, you're not going to lose additional points because you decided to get sleep. Right, sleep is very important. All right, so anyway, the points will resume 6 o'clock the following day. All right, it'll start counting down 35, 40, 45, so on, until it reaches 60 points. And so if you turn it in 2 days late, you lose 60 points. And then after 9 calendar days, we're not going to accept any things. Okay. If life happens and you need an extension for your homework, that's totally fine. Okay. If you have some kind of documentation, right? You got sick, go to the doctor, get a doctor's note, turn in the documentation with the homework, all right? If you email me the stuff, I have so many students, all right? I can't keep track of everybody's email submissions and things like that, all right? So just when you submit your homeworks, it allows for multiple file submissions. Submit your homework submission plus the document, okay? Turn them in together. And then when the grader is going through the homeworks to grade them, they'll say, oh, this homework came in late. Oh, there's a note from the doctor. And then they're not going to take off any points. Okay? So, is that okay? Does that make sense? Just turn in your whatever note, whatever it is, your reason for the late homework in with the thing. And we'll just give you an extra 3 days, 72 hours for that, okay? And if whatever circumstance is going on in your life and it requires more than three days of extension, then come talk to me, okay? I try to be pretty reasonable, and so we have that, okay? Homework regrades, your homeworks are graded by other grad students. They do their best. Sometimes they make mistakes, okay? All regrades I ask to be done in person, okay? Your TA is also authorized to make changes to your homework grade, okay? So you can talk to your TA, you can talk to me. All regrades have to be done in person. Please don't email me and say, like, I lost points for this and I don't think I should have, okay? That might very well be the case. But there's just too many emails for me to handle, so it'll best be done in person. Okay. All right. Exams. If you miss an exam, come talk to me. I'll ask for documentation, and then we'll go there. All right. I already gave my spiel about attendance. Okay. And there we go. Oh, we're going to have a class Piazza. And this is how the Piazza discussion board points will work. Okay? 12 contributions. You need to make 12 contributions in total to get your full 3 points. Okay? That's basically about 1 contribution a week. All right? It's not that hard. You just have to say something. Okay? Ask a question, answer a question, add a follow-up discussion comment, something like that. Those count as contributions, okay? Don't just spam junk to the Piazza board, okay? Don't just say, like, same question. That's not helpful, okay? So anyway, we have that. Okay, academic integrity. Do your own homework, all right? I know it can be tempting to copy someone else's homework, all right? You're not going to learn that way. You gotta, the learning happens in the struggle, right? People understand this for like every other aspect of life, but for some reason, students often feel like learning should come easy or naturally, and that's not always the case. Okay, you learn when you struggle, right? If you want to get better at a sport, you have to practice, and you have to practice in a way that that forces you to struggle to get better, right? You practice. If you're going to practice basketball, you have to practice taking shots that are difficult to make, that in the beginning you are missing a lot, and eventually you start getting better, okay? If you only practice layups because you keep making those and you're good at them, you're not going to get better at anything else, okay? You're not going to, and then, you're not going to get better by watching somebody else practice basketball. And in the same way, if you just copy someone else's homework, that's not going to help. Okay. I hope, none of you face any kind of traumatic incidents, but I also know life can be hard and ugly. And so, the university has a lot of resources to help you in if you ever face gender discrimination or sexual violence for anybody. And so we have resources. Please use them. And same with mental health and student well-being. We have resources, and I know CAPS can get very busy during the quarter, and so I'm always happy to support any kind of funding for that. But we do have resources, and people are here to help you and support you. So please make sure that you don't just sit alone and be by yourself miserable. That's not the way to be. I think most of you should be aware of the office or the Center for Accessible Education. If you have any kind of disabilities and need accommodations, go talk to them. And okay, and then course grade changes. If we've made a mistake, come see me in person. Again, I don't like to do grade changes over email, so just come see me in person. We'll deal with it. And then if you have any questions about, it says undergraduate, I'm like the least qualified person to give you advice about your life and your future. But if you want to come talk to me and ask about grad school or things like that, or jobs and stuff like that, I'm happy to just give you my 2 cents worthless opinions and stuff. But we have that. Okay. All right. Any questions before we get started? No. Okay. Then let me see. I'm going to try. I started taking notes using OneNote. Oh, this was in the other class. We'll create a new section here. This is going to be 102. Oh, that's 103. 102C. Okay. All right, and this is week 0, Friday. Oh, it doesn't quite fit. What's up with that? Hmm? There we go. All right. All right. So this is 102C. Monte Carlo methods. Okay, so let's first talk about, today we'll just talk about big picture ideas of what the course is all about. And, all right. What do you guys know about Monte Carlo methods, or the Monte Carlo? Okay, so the Monte Carlo is a casino. It's a casino in, where is it? Where? Monaco, yeah. Okay, the Monte Carlo is a casino in Monaco. It's like, so when we hear Las Vegas, if we think of like, where do you go for gambling? You think of Las Vegas, right? Except if you're in Europe and you say, should we go for gambling? You think the Monte Carlo, all right? And so anyway, the thing about a casino is you've got all these games of chance, right? You've got random games and the games have been played many, many, many times, right? And that's kind of the idea. Okay, the big idea here for Monte Carlo methods is that we have these difficult math problems, kind of probability-based math problems, and maybe the math is too hard for us to do analytically, okay? So we'll say we have some probability-based math problems, okay? Probability-based math problems, we might call these like stochastic. Okay, and the math might be too difficult for us to answer directly. Okay, so the math might be too difficult for us. And so Monte Carlo methods use randomness, and I might write computer-generated randomness, we use computer-generated randomness to find estimates estimates of the answers we seek. Okay. You guys all took Stats 100B? Anybody not take Stats 100B? Okay, so that's good. All right, what did you guys learn in Stats 100B? I will just assume you are shy. Okay, so in Stats 100B, you studied random variables and distributions, right? You learned, like, I don't know, the exponential distribution, and you learned stuff like how do you find the expected value, right? Like the kind of the mathematical definition of the expected value and the variance, right? So we'll just say recall Stats 100B, or your kind of your mathematical statistics course, and you studied studied random variables and distributions. Okay, and you learned the definition of the expected value of a distribution. All right. So let's say, does anyone remember the definition of the expected value? So let's say x is defined by some PDF p of x. So it's a continuous distribution PDF. All right, what is the expected value of x? How do we calculate this? Yeah, it's the mean. Yes, that's correct. All right, it's the integral of what? X times p of x dx, right? From minus infinity to infinity, or on the domain of x. Okay, and so this is how we calculate the expected value, right? And then similarly, you know, distribution, also learn variance. And things like that. Okay. In this class, we want the same kind of stuff. We want to find the expected value of a distribution. We want to find the variance of the distribution. But this part, doing the integral of x times p of x dx, that might be really hard, okay? If, depending on what the PDF looks like, this integral could be impossible, okay? So in our class, we want to learn the same kind of stuff. We want to learn expected value and variance also. Okay. But, you know, depending on the PDF, this integral may be very difficult or impossible. Okay, so what we do is we will learn techniques to generate a random sample drawn from p of x. Okay, so we may learn, or methods to generate a random sample drawn from p of x, okay? And we can use that to then get estimates of the expected value and variance, okay? Expected value and variance. Okay, so kind of the big picture idea is, you know, we have problems, and we're going to use randomness to help us find estimates of our answers. Okay. I think I wrote that. Monte Carlo methods use computer-generated randomness to find estimates of the answers we seek. All right. All right. And so, yeah, we're going to learn methods to draw a random sample. So just for example, so e.g., right? What is the expected value of some distribution? Okay. Well, what we will do is we generate a random sample. We'll call this x super n, okay, which is equal to kind of the set just x0, x1, x2, dot, dot, dot. From the distribution p of x, okay, and we will use the random sample as kind of a stand-in we use the random sample as a stand-in for the population, and then you know, we estimate the mean, the expected value of x, by taking the sample mean. Whoops, did something here. So we're going to take the sample mean of our random sample. Okay. Okay, let's let me just do the simplest little demo here. All right, so let's say x comes from a we'll say exponential distribution with lambda equal to 3. Okay, we'll say x, so this is an example. Okay, x comes from an exponential distribution with lambda equal to 3, and I ask, what is the mean of x? And what is the variance of x? All right. Do you guys remember the properties? So if you forget, you just go over to Wikipedia. All right. And then you just say, all right, well, I want to learn about exponential distribution. Oh, it even shows up already in Google? Look at this. This is amazing. Okay. So Google just says it's going to be lambda to the -1 and lambda to the -2. Oh, okay. Well, that's easy. Normally, I had to do an additional click and scroll down over here, but Google has made my life even better. All right. Thank you, Google. So anyway, I mean, we know the answers, and maybe you had to like prove that the expected value of this was, or at least derive it in 100B, okay? This is how we do it in Monte Carlo, all right? Well, it's convenient for us because we have the random exponent function in R, right? So I'm going to just say x is, wow, it is really hard. I'm going to need like a keyboard. Oh, dear. Okay. All right, I got to use equal like some peasant here. Okay. All right, so we're going to do R is exp. And let's ask for like, where's the caret button? How do you get more symbols? Do you not have more symbols? Oh, there we go. Okay, so we'll ask for like 100,000 of these things, and then I think I say rate is equal to 3. Okay. Does Control Enter work? All right, so there we go. All right, and then we can ask for like histogram of x, right? All right, yeah, that looks good. All right, so anyway, well, it's easy for us because we have a function that generates values from the exponential distribution, right? But this is just kind of the idea. So, you know, you forget how to calculate the mean or whatever of some random variable. All we do is we've generated 100,000 random values of x, and then I just ask for the mean of x, okay? And I do this, and it gives me 0.3318, which is very close to the actual value of 1/3. So that's pretty good. And then we could ask, all right, what is the variance, right? What's the variance of x, okay? And it gives me 0.1108, which is very close to the true value of 1/9, right? So the true value is 1/3 for the mean and 1/9 for the variance. And here we have estimates based on a random sample of 100,000 values drawn from the exponential distribution. Okay, so let me just... All right, I don't know how to, oh, there we go. All right, so let me just take a little screenshot of this. All right, and I want to copy that, and I want to paste that into here. Okay. Okay. All right, we'll end there. We'll see you guys on Monday.